it's going to be a bit more interesting in this video because we're going to actually make a timer that we can set with an interval, and after it overflows, it increments the number of overflows, and then you can use that to time things in your program. All right, so the timer I'm using lives in system.threading. Right, so you have to add that to your using list, and then say timer 1, and we're going to make it a static. And then we're going to say start, make a function public start timer, right? And I'm going to say timer 1 is new timer, and then look, timer 1 wants a argument timer callback, right? So let's just, to see what more about the argument is, you just click on the thing and press S12, right? And it says, well, okay, one of the overflow methods, or the construction overflows, is you're just going to give it a timer callback, but we want to also program the period. And the period is, the time in which it overflows. So first, to find out what this is, press S12 again. It says it is a public delegate void timer callback, and it requires an object state. Now, there are plenty of videos on YouTube that explain what a callback function is, and we're going to just make one. So we're just going to say a public timer 1 callback. No, public void timer 1 timer callback object state, right? And then we're going to say inc number of counts. All right, so when timer 1 overflows, it calls this callback function, and that one calls increased number of counts. All right. So we're going to say new timer, and we're going to give it timer callback. It also wants object state, which we don't have. It's going to pass null. Int due time is the time when it's supposed to start in, so in how many seconds it's supposed to start for a delayed start, 0. And the period is interval milliseconds, right? So we've created a new timer that's going to run every interval millisecond period. Then we're going to also, what do you want? Return type. Oh, public void. Public void start timer. Then we also want to dispose of the timer once we're done with it. Dispose timer, right? And we're going to say timer 1 dot dispose bracket. There you go. So that's that, and we're going to say F6. Right. I've cleaned up the main a bit, so we only have the interval millisecond with the time in which we want to overflow. We're going to null the number of counts. Then we're going to start the timer. Right. There you go. A bit of more space here. Okay, well, we're gonna create a get number of counts. And we're gonna say if the number of counts is equal to 0, all right, then in a while loop, you must keep asking for the number of counts. Continue, see, and you're going to give it a indicator, there you go. Right, so in the beginning, the number of counts is 0, start the timer, and ask for the number of counts. Is it still equal to 0? Yes, keep going, keep going, keep going. Something important, we have to put in a wait of a few milliseconds, otherwise we make the problem will not really work actually, because it will just commit all its activity in this loop, and the timer won't have anything itself. Right, so we're gonna pass these out again. Right, and we have our reference destroyer, but we also have our dispose timer to get rid of our timer, and then pass this there, pass this there. If you're going to run this once, it's going to end up at 1. It's not very exciting, but if you then put this in a while loop, then you could say, for instance, as long, let's see, okay, as long as I is smaller than 5, for instance, then you must continue. So now we're going to see one, oh, okay, why is this? And then to make this work, we have to make this a shift register and put in the latest value, right? So start with 0, compare with 0, this is 0, this at some point will get 1, because we started the time will overflow. Then we'll exit this loop, hit this comparison thing. Is this 5 yet? No. All right, let's go back here. But we passed the 1 here. Now it compares to 1. Is 1 equal to 1? Yes. Okay, keep running. This will be 2, etc. Then we're going to dispose the timer and then get rid of the evidence, basically. See, 1, 2, 3, 4, 5. And it gets 6, because that's the exit condition of this loop. Is unequal to 5, right? So we can also increase this to 500, right? And that's how we do polling. So we, for every 200 milliseconds, 200 times per second, so every 5 milliseconds, we're going to ask, is your timer increased yet? Yes, 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 yes. And then we're going to do other stuff. So you can put your other stuff in this bit. And this is basically a wait function on the timer.